So hello again. This is Roger Kochbar for the Bioelectricity course. We're in week 7, the final lecture segment, the week in review. This will be segment 12 for this week. We've watched carefully, just like this guy, watching carefully what's happening with these waveforms. First thing we observe is that extracellular voltages were present across fingers. In fact, they're present across anybody's fingers. You see a complex wave shape when you do such a recording, though a heartbeat is visible. The second thing we observed is that a much simpler wave shape, largely biphasic, is seen from an extracellular electrode near a single fiber. That leads one to the conclusion, which is correct, that when you see complicated multiphasic wave shapes, these are signals from many different fibers or many different sources, all overlapping one with another, because the signal from a single fiber is a very simple wave shape. In the wave shape we saw from this simple fiber, and the wave shape in the hearts, and all the other cases that I'm aware of, the leading edge of the excitation wave, seen from outside the fiber, is a positive voltage. Similarly, the trailing edge is a negative voltage. That corresponds to the location of sources of current and sinks. Current coming out and current going in. It comes out ahead of the excitation wave, goes in behind it. The sources and sinks are readily identifiable from the curve of Vm of x, and certainly from Im of x, if you have it. Finally, even though the geometry is hugely different between a single fiber and excitation waves in the heart, some of the basic principles evident with a single fiber again apply even in a very complex organ such as the heart. I think there's a general truth here, which is when you look at specific cases, often they appear very, very complex or different or have unusual geometries, but when you look at them mechanistically, often the sources are pretty simple. I've listed here all 5 of these as our week in review. I won't read them again, but these are rather significant conclusions that have a significance not just for us, but a general significance within waveform interpretation. Before concluding this week in review, I wanted to mention to you that this subject, the interpretation, the recording and interpretation of extracellular waveforms, is an enormous and wide-ranging subject. It's because interpreting extracellular waveforms is easy, it's inexpensive, it gives you a lot of information without much effort, and is valuable. One aspect of its wide-ranging nature is the fact that there is a substantial industry that's devoted to the manufacture of specialized instruments for recording and display of electrocardiographic, but also electroencephalographic, electromyographic, and all manner of electrical waveforms from all sorts of different organs. This is a worldwide industry that employs thousands of people. As it designs instruments, it pays attention to a lot of factors. Well, of course, the basic principles, but also safety, simplicity of use, reliability over a long time, the value of the information as it being easily presented to the physician or other user. It's actually a rather complicated design, even though the underlying idea, measure voltage with time, is relatively simple. One of its interesting dimensions is that the industry wishes the results to be easy to interpret, so therefore they tend to incorporate a lot of signal processing between the measurement and the display. That's a great thing to do, but you do have to be cognizant that all this signal processing may actually change the signal you want to look at. So there is a balance that has to be struck. Finally, the modes and principles of interpretation vary by organ system. What's significant in one case is not very significant in another. So it properly has become the domain of specialists in the diseases of different kinds of organ systems or other measurements that are made. And it's very highly developed so that, for example, one sees whole textbooks for cardiologists or cardiology students related to waveform interpretation for cardiac purposes. I end this review with the picture of these statues, which are part of the Duke University Chapel. More people watching over us. As they watch us, we watch them. That's very good. Thank you for watching.